This is question 16 from JMC2015. The diagram shows a square inside of an equilateral triangle. What is the value of x plus y? So in an equilateral triangle, three angles are all equal and equivalent, and they are 60 degrees. All of the angles in a square are right angles and are 90 degrees. Angles on a straight line are 180 degrees, so the sum of these two angles here and the 90 degree, well, the sum of these two angles, which I'll label A and B, are 90 degrees. And then on this triangle here, we know the sum of one triangle is 180, so we know the sum of both triangles is 2 times that value, 360. So I know that 2 times 60 from these two. We know A plus B is 90, because we just worked that out, so we can put that as 90. And then we know, what we don't know is x plus y. And that all equals 360. Let's simplify that. So we've got 120 from this, 90 from that, makes that 210. Plus x plus y, 360. X plus y is therefore 150 degrees, and that is D. This is JMC 2015, question 17. We can see there are 4 statements by the knave of hearts, clubs, diamonds, and spades. Question is, how many of the 4 knaves were telling the truth? So really we just need to consider the possible cases here. So the knave of hearts, I stole the tarts. He's either telling the truth or he is lying. Knave of clubs, the knave of hearts is lying. If that's a true statement, then the knave of hearts didn't steal the tarts. The only place that is going to work is here. Whereas if the knave of hearts is telling the truth and he did steal the tarts, then this would be a lie. And you can already see this becomes confusing very quickly. And reasoning is one of the tough problems on this test, but they have one pretty much every year. Next, the knave of clubs is lying. Well, in this case, that must be true. It's simply going to be the opposite, and it must be false. And I hope you can see the same reasoning. This one must be false for that to be true. So, the knave of clubs is lying. That must be true because he's lying about the fact that he stole the tarts. So there's only 2 possible cases here. So either the knave of hearts stole them, or the knave of hearts didn't steal them. We don't know the answer to that. But we do know in either of those 2 cases, there's only 2 truths. So we do have enough information to state that the answer is 2. But we don't actually know the reality of whether the tarts were stolen. This is JMC 2015, question 18. Each of the fractions 2637 over 18459 and 5274 over 36918 uses the digits 1 to 9 exactly once. The first fraction simplifies to 1 over 7. What is the simplified form of the second fraction? So you'll see this is the question 18, so often this would be quite a tough question, although this one here, they've put in quite oddly, and it's kind of a nice question. Really comes down to whether you see the solution or not, or you try and work through things difficultly, but I can tell you that depends whether you're good at mental arithmetic, I suppose. Times 2 over 2 equals 5274. over 3698, 918. Therefore the answer is just B. Hope you can see that the Z fraction is just double the top and double the bottom, therefore it's the same answer. Yeah, this is it seems out of place, this question, and it just rewards those who just kind of look at things in maybe perhaps a little bit different way than trying to simplify the fractions all in one go and all that kind of thing. Sometimes you need to take a little bit of a step back on the picture. This is JMC2015, question 19. One of the following cubes is the smallest cube that can be written as the sum of 3 positive cubes. Which is it? I'm just going to write out the first few cubes. And you'll see that some of them are already in the question. There's nothing saying we can't use the same cube multiple times, like 1 cube plus 1 cube plus 1 cube. But you can see there's no way we're going to be able to get 27 from these numbers. 8, 16, 8, 24 maximum, that already goes above. No. Similarly with 16, I can't see any way here, because 27 plus 27 is 54 plus 8. No. 125 again, we're not going to be able to do that simply because 64 plus 64 is already 128. And if we did 2 times 3, 54 plus 64, we only get 118. And that one isn't going to work. 216. So that one, yeah, I can see a solution for this one already hidden in the question almost. That 3 cube plus 4 cube plus 5 cube does equal 216, and that is the next cube that we can actually form. It doesn't matter how we form it in this case, it just can be formed, whereas the ones before it can't. So the answer is D. This is JMC 2015, question 20. The diagram shows a pyramid made up of 30 cubes, each measuring 1 by 1 by 1. What is the total surface area of the pyramid, including its base? So my initial thought is to slide the blocks. So rather than having it in the center of the blocks here, just shift it to here, and then there'll be 7 blocks. 3, and you can do the same. We'll shift this one to here, and then there's 3 more on top that are left. Which means from top down, we're going to see 1 from the top, then 3, then 5, then 7. And then from each side, 1, 2, 3, 4. Each side contributes 10, 1 plus 2 plus 3 plus 4. And there are four sides that we can view this from. So we've got 1 plus 3 plus 5 plus 7, which is 16, plus 4 times 10, plus the bottom, which is another 16, because it's a 4 by 4 square. This equals 32 plus 40 equals 72, and that is C.